Okay, so I'm just going to finish through these notes quickly from what we did in class. And we had left off at number 5, I believe. So on number 6, you do not have common bases, but you do have parentheses raised to an exponent. So this is 9 to the third to the 3 halves. So power to a power we multiply. So that would be 9 to the 9 halves over, and then 4 to the second has to be raised to the 3 halves. So power to power here would be 2 times 3 halves would be 6 halves. And then we can kind of simplify each one of those. So this would be the square root of 9 to the 9th power over, now this 6 over 2 is the same thing as the whole number 3. So I could just put that as 4 to the 3rd power. And I'd be pretty good, but I'm pretty sure you all know as well as I do that the square root of 9 is 3. So 3 to the 9th power over 4 to the 3rd power would be the simplest. We can't do any subtraction here because we do not have common bases. Okay, here we get to, again, common bases, add our exponents. So negative 2/3 plus 1/3 is negative 1/3. So this would be x to the negative 1/3. Now the negative exponent rule, which is the only one we did not talk about in class, you cannot leave a negative exponent. You need to move that base either from a numerator to a denominator or from a denominator to a numerator. Now this is currently in a numerator technically, so I would have to move it to the denominator to be a positive exponent. And now I can go back to radical form. So 1 over, and x to the 1/3 power is the same as the cubed root of x. Okay, on something like this, we would multiply our 2 times 4 per usual and get 8. But x to the 1/2 times x to the negative 5 halves is multiplying common bases of x. So I'd have to add those exponents. So 1/2 plus negative 5 halves is going to be negative 4 halves, which is negative 2. So it'll be x to the negative 2nd power. So I don't need any radicals here because I don't have any fractional exponents, but I do have a negative exponent that needs to be moved to the denominator so that that can become a positive 2. So x to the positive 2nd power, and that would be your final answer. Okay, same thing here with division. The 10 divided by 2, those are just basic numbers, so they're going to be divided per usual. 10 divided by 2 is 5. But here we have common bases being divided, so we need to subtract those exponents. So 1/3 minus 2. I need a common denominator, so that's technically over 1 right now. Multiply by 3, multiply by 3. I get 1/3 minus 6/3, which is negative 5/3. So your common base of x to the negative 5/3 power. Now, negative exponent, move it to the denominator. And fractional exponent, 5/3, you will probably have to change into a radical. So 5 over the cubed root of x to the 5th power. And that's your final answer. Okay, on to the back. With parentheses, everything in parentheses needs to be raised to the power. So 3 to the negative 2nd, which we'll deal with that negative exponent in a minute. X to the 1/4 to the negative 2nd, power to power, we multiply. So 1/4 times negative 2 is negative 2/4. Okay, both of those being negative exponents, they both need to move to the denominator. So that moves to a denominator, that moves to a denominator. And so we placehold the numerator with a 1. So over 3 squared over x to the positive 2/4, which I'm going to reduce now to 1/2. So the 3 squared I can make a 9, and the x to the 1/2 power is the same as the square root of x. There's your final answer. Okay. exponent rules wise, I would distribute here, and it would be 2, and then x to the 1/2 times x squared. When you add 1/2 and 2, it's going to take a little side work. So that's 1/2 plus 4/2, because that was over 1. And that's 5/2. So 2x to the 5/2 minus, and when I distribute here, I'm just going to get 4x to the 1/2 divided by x. So this is going to require some common base work. This is technically to the first power. So I'll have 2x to the 5/2 minus, and then 4, and then subtract your exponents. 1/2 minus 1 is 1/2 minus 2/2, which is negative 1/2. So 4x to the negative 1/2. This is going to turn into a radical. 2 times the square root of x to the 5th minus, this needs to move to a denominator, so 4 over x to the 1/2 power. And then your x to the 1/2 power can change to the square root of x. Okay? This one is kind of a combo. It's got a radical in there right from the beginning. So the first thing we should do is change this to x to the 1/2 power. Okay, now when you're dividing a trinomial by a monomial, each piece has to be divided by x to the 1/2. So on my first term, 2 divided by 1 is a 2. X to the 4th divided by x to the 1/2. 4 minus 1/2 is going to be 8/2 minus 1/2, so 7/2, so x to the 7/2. Minus, we're on to our next term, x squared, so divided by x to the 1/2, 2 minus 1/2 is going to be 4 over 2 minus 1 over 2, 3 over 2, so x to the 3 over 2. And then last term, we have negative 3, and it's x to the first power technically, divided by x to the 1/2, so 1 minus 1/2 is 1/2, so 3x to the 1/2 power. And then we can put all of those into radical form. So it would be 2 times the square root of x to the 7th minus the square root of x to the 3rd minus 3 times the square root of x. Remember, the only thing being raised to that 1/2 power is the x there. And so that would be in radical form. Okay, a little bit back to the basics. Common bases being divided, we subtract. We just have to think about what is 5 root 3 minus 2 root 3. 5 root 3's minus 2 root 3's is 3 root 3's. So when I subtract these, I get x to the 3 root 3. Okay, here power to power we multiply, so we have to remember root 2 times root 3 is just root 6. So this is going to be x to the root 6 power. And then here we have a choice. We can square the numerator and square the denominator and then worry about dividing common bases, or we can simplify here first by dividing common bases and then square the answer. I think I'm going to start inside, simplifying inside first. So I need to subtract pi minus pi over 3. This is technically over 1 right now. So that's going to be 3 pi over 3 minus pi over 3, which is 2 pi over 3. So this is going to be x to the 2 pi over 3. And then when we square it, we're going to raise a power to a power, which means multiply. So 2 pi over 3 times 2 is 4 pi over 3. Okay, down at the bottom, again, when they start with radicals, put them into exponential form first. So that cubed root is going to make this whole thing raised to the 1/3 power. That means 64 is raised to the 1/3 power. And that means y to the 6th is raised to the 1/3 power. Now, the numerical portion can kind of be done on your calculator, or you may choose to still think of that as the cubed root of 64. If you type that into your calculator, you're going to get 4. Here you have to know your exponent rules. There's no calculator that's going to help you. You have to know power to power means multiply. And 6 times 1/3 is 6/3, which is the whole number 2. So that ends up being y squared, and you're done. We had done 17, and then here is 18. Your 14 divided by 2 yields 7. You have x to technically the first power divided by x to the 3/4. So that's common bases being divided. We need to subtract 1 minus 3/4. So that's technically 4/4 minus 3/4, which is 1/4. So it'll be x to the 1/4 power. Your y has no other y, so I'm just going to bring that down, y to the 1/3 power. And then technically there's no zeros, but it's over z to the -6, so that can just move up top as being z to the 6. And that's your final exponential form. To go into radical form, we would do 7 times the 4th root of x times the cubed root of y, z to the 6. There is one other possibility with this one, and that would be that they get a common denominator for all 3 of these exponents. So that would be 12. So that would be 7x to the 3/12 times y to the 4/12 times z to the 72/12. I don't know that they would do that necessarily, but they might just keep z to the 6 since it's a whole number. They might just kind of keep that there. But for these two, the reason they might do this is because if they're both to the, we have a 7 and we have a z to the 6. But because both of these are have a denominator of 12, they might choose to think of this as x to the 3rd times y to the 4th to the 1/12, and kind of bring that 12th out, and then you'd have 7z to the 6th, and then the 12th root of x to the 3rd, y to the 4th. So either one of those would work. So that's all for the notes, and then your homework, obviously, we received in class.